Hello and welcome to the Bettersize Laboratory. My name is Zhibin Guo. I'm the application engineer at Bettersize. Today, I'm going to introduce the latest generation of particle size and shape analyzer, Bettersizer S3 Plus, which combines laser diffraction and dynamic image analysis. It offers unique and comprehensive particle size and shape characterization possibilities from the nanometer to milliliter range. Well, how does the Bettersizer S3 Plus work? This instrument includes a laser diffraction system, an image analysis system, an automatic dispersion system, and a specialized software. When performing measurements, we add the sample and transfer it through the circulation system to the laser measurement area. The laser emitted from here will irradiate particles and produce scatter light. The photodetectors located here will receive the scatter light and then convert them into electrical signals and transfer to the software for analysis. The software then analyzes these electrical signals according to mere scattering theory to provide the particle size distribution of the measured sample. More importantly, the Bettersizer S3 Plus also has an image analysis system. It offers two CCD cameras, including 0.5-fold and 10-fold magnification lenses that capture around 10,000 particles per minute. Therefore, at the same time during the measurement, the LED light is irradiated to the particles and then imaged only CCDs. Then the high-speed data cable will transfer these images to the software for image processing and analysis to provide both particle size and shape information. Depending on your applications, the Bettersizer S3 Plus can use laser diffraction or image analysis alone, or combine these two methods to present more comprehensive information of your sample. The versatility of the instrument makes it a popular choice in both industry and academic labs. Well, let me show you what the Bettersizer S3 Plus can offer you by measuring a sample. This is one of the samples that's sent to our lab. The composition is silicon carbide, which is a commonly used abrasive as well as a typical semiconductor material. Today, I'm going to use the Bettersizer S3 Plus to measure its particle size and shape as a demo.
This is the software interface. First, we right-click to create a new project for this test. In the pop-up window, enter the information required by the project. Here, I type in test as the project name, and I choose the laser and image combination project as the project type. And I type in my name in the creator item, then click OK. Now this project has been created. We double-click to enter this project. As you see, there's no test data now since it's a new one. Then we can start testing. Click on the Test Process button and the test window pop up. Under the Document tab, input the original information such as sample name, sample number, medium, measurement time, and so on. This information will be printed in the report finally. Here we enter the sample name as silicon carbide. After the input is completed, click on the Option tab. There are many parameters to be entered. And note these parameters must be set correctly, because they directly affect the accuracy of the results. Optical parameter refers to the refractive indices of the sample and medium. Every material has a refractive index, and it is an important parameter for the mere scattering theory. So the selection or input of the refractive index is critical to the measurement results. The software already contains the optical parameters of more than 200 materials and of 28 dispersion media. In addition, there is an innovative feature called refractive index measurement in the Bettersizer S3 Plus, a useful tool for scientific researchers. I will cover this feature later. Here, we search for silicon carbide. See, its refractive index appears. Let's double-click to select it. As for the dispersion medium, it is to make the sample in a uniform, dispersed, and easy to transport state. Dispersion medium should be transparent without impurities, and make sure there's no chemical reactions between the sample and medium. There are many liquids that can be selected as the dispersion medium. For this measurement, we choose the most commonly used one, water. So choose water as the dispersion medium, and the refractive index is shown here. As for test parameter, we can just use the default parameters for this measurement. And finally, remember to click on the Enable Combine Test button in order to perform the combine test. Up till now, we finished the parameters input. Let's click on the Test tab for the actual operation. Several new windows pop out instantly. I will explain them in detail later. Let's focus on the test window first. The Bettersizer S3 Plus has 3 measurement modes to choose from: auto test, general test, and refractive index measurement. Refractive index measurement is an innovative feature of the Bettersize software. As we know, when using mere scattering theory to provide the particle size distribution, the refractive index of the sample must be known. What if we don't know it? Then this function will be very helpful as it can be used to calculate the refractive index. And this feature ensures the accuracy and reliability of the results of unknown samples. General test that is suitable for unfamiliar samples, which require methodological studies. It allows you to control your measurements in multi-steps, and it is recommended to determine appropriate measurement parameters in the general test first, especially for unknown samples, before using the auto test. As for auto test, as long as SOP, standard operating procedure, is set appropriately, the auto test function can be used. The advantage of auto test is not only to simplify the operation, and more importantly, to make the measurement results independent of the operator, ensuring the repeatability and accuracy of the results. In this demo, we will use auto test to measure silicon carbide. First, let's click Set SOP. The reason why the sample can be automatically measured is that SOP has been set up in advance. These operating procedures include water level determination, disperse sample, test sample, save result, and so on. Generally, the SOP settings vary for different samples. The dispersion time is set to 30 seconds for this measurement, and the circulation speed is set to 2000 revolutions per minute. And we will measure 3 times in a row to check the consistency among the results, namely the repeatability. After completing the SOP settings, we click OK to return to the test window. In the upper right corner, the current status of the analyzer is displayed here, and the system is good and ready to go, so we can start the measurement at any time. The auto test of the Bettersizer S3 Plus is a smart and automated function. All you need to do during the measurement is to click Auto Test button and add sample once. Then the detailed and comprehensive results will be given. Let's click on the auto test now. The upper right corner here shows the progress of the test. The first one is level sensing at water, and the instrument starts to automatically adjust background that ensures the system is always in an optimal state. Then testing background. When it indicates background test finished, please add. We proceed to the next step, adding samples. A laser analyzer provides the particle size distribution of powders by measuring only a small fraction of samples. Therefore, the sample to be measured should be sufficiently representative, which is strongly related to the sampling method. Here, I use a small spoon to sample and pre-disperse it into the water in the beaker, and make sure that it's well dispersed in the water. Then I pour it directly into the circulation system, and please keep in mind to pour all the sample in the beaker without any part remaining. After the sample is added and the required obscuration is reached, the instrument starts to disperse the sample. The previously set time is 30 seconds. After the dispersion is completed, the instrument will start the analysis automatically. Well, let me go over these windows in brief during the dispersion process. Firstly, the test window belongs to the laser diffraction system of the Bettersizer S3 Plus. Using the Bettersize dual lens and oblique incidence optical system, the Bettersizer S3 Plus has extremely high accuracy for very small particles. Our patented technology provides for the focusing and collection of the backscattering signals at a very wide angle range from 0.02 to 165 degrees, ensuring excellent detector resolution compared to other systems available in the market. On the other hand, other windows belong to another system, image analysis system of the Bettersizer S3 Plus. The upper left window is the real-time shooting video, and the lower left window is the real-time analysis result, including a histogram, typical values, and a scatter plot. And the right window is the individual particle image, which shows the image results. All the windows are provided by the image analysis technique. Well, within a short time, 3 measurements are finished. It can be seen that the deviation of 3 results is very small, and the repeatability meets the ISO standard, indicating the results are stable. And we can also double-click on any result, and its detailed parameter will pop up. In the particle view window, we can arrange the particles with different parameters. Here I choose descending order and sorting by diameter from largest to smallest. For this silicon carbide sample, we find that one of largest particles is around 200 microns, and most of particles are irregular. We double-click on the individual particle, and detail shape parameters such as area, diameter, LD ratio, and circularity will appear immediately. Any particle can be clicked on, which is very intuitive. Next, we are going to check what will happen if we add a small amount of large and round zirconium beads to the sample dispersed in the Bettersizer S3 Plus. As we know, an exact detection of large particles using laser diffraction is challenging, especially for particles with a broad size distribution, because the majority of small particles dominate the statistics. Then how about the Bettersizer S3 Plus with the combination technique? Can it identify the small amount of large particles successfully? Let's see. Similarly, I pre-disperse the zirconium beads with water in the beaker. As we see, the number of zirconium beads is very small compared to that of the silicon carbide powder, and we confirm it's well dispersed in the water. Then I pour it directly into the circulation system and rinse it with the water to make sure that no sample remains in the beaker. After adding the zirconium beads, we disperse the sample again for 30 seconds, and the test starts one more time. Now something new appears in the screen. The real-time video in the upper left corner shows the presence of some large particles that drift across the video rapidly. As shown in the typical result window, the scatter plot shows actual points with high circularity at around 350 microns. And have a look at the single particle view on the right. The images of large particles are constantly being captured. Therefore, by combining laser diffraction with dynamic image analysis, it turns out that the Bettersizer S3 Plus takes advantage of both methods, and can measure very small and very large particles precisely in only one system. Now the measurements are finished, so we close all the testing windows. These results are automatically saved in the build project and arranged in order. The average value is calculated by the software. We select any result and right-click on it. You can modify the input parameters through real name or real analyzed sample. You can view laser and image results separately and print sample report. You can even select them and check their trends through the line chart. Or we can select a result and double-click to enter its detail page. You can zoom in or zoom out to see it clearly and print it as an Excel or PDF report. In addition, compare with the only one peak in the pure silicon carbide sample. In the mixture sample, a new peak appeared at the coarse end, indicating the presence of zirconium beads, and 2 peaks are differentiated clearly, to verify the high resolution of the Bettersizer S3 Plus.
Okay, the entire measurement is done. As we see, the Bettersizer S3 Plus is a powerful particle size and shape analyzer. The laser system and the image system are combined into only one device to offer you the most comprehensive information of your sample. This is the end, and I hope you find this video helpful. Please be sure to leave any comments or questions below, and check out the Bettersize website for more detailed information on each instrument. Thanks for watching.